coming to this thing called effects of electric current. Now, in the effects of electric current, we have the first effect, chemical effect of an electric current. Alright, now in this chemical effect of electric current, you'll see down here that one of the things that we use is electroplating. You're missing the practical, which we'll conduct on Thursday or Friday. And you can see down here that this is the positive side of the battery of the cell. So the positive side of the cell, we call this the anode. The negative side of it, we call it the cathode. The exact mechanism of how this thing works, I'll tell you during the practical itself. Okay, basically what happens is that the positive ion will move in the electrolyte and then be attracted over to whatever you want to plate here. So whatever you want to plate, you always put it at the negative side. You call it the cathode. Alright, so let's say you want to plate copper, plate this spoon copper or silver, in this case silver. Alright, so what happens is you put a silver bar here. Alright, then the silver bar, the ions will actually migrate over to this spoon, and then the spoon will be coated later on with a layer of silver. And then this silver bar here will get depleted, will get smaller and smaller. Okay, another thing you need to talk about is your magnetic effect of an electric current. A magnetic effect of electric current, right? There are three ways to increase the magnetic effect of electric current here. Now, one way is to increase the number of turns of coil. Please note there's only one coil, but there are many turns of coil here. Another way of doing it is by inserting an iron rod, anything that is magnetic. In this case, it can be steel, it can be nickel, it can be cobalt. Alright, but down here it's written down as iron. Okay, what it serves to do is to concentrate the magnetic fields through here so the magnetic strength gets stronger. Another thing you can do is to increase the amount of current that passes through the coil. So in this case, it will be able to get more, it will be able to attract more magnetic material actually. Alright, now heating effects of an electric current here, okay, we usually use nichrome wire. Alright, nothing much to it, but I want to draw your attention to this thing called tungsten black bulb. Now this is a coiled filament. This is double coiled. You can see down here that it's actually coiled in the first place, and then you coil it further again. Reason is because you want to increase the R. When you increase the R, the resistance of the wire of this thing here, it will increase the amount of heat generated. If you have to increase the amount of heat generated, right, then your tungsten filament will be able to get hotter faster, and then the light will come faster. Okay, right, basically that's it. Alright.